Hello guys, so we're here today to talk about rates of change. So we've been talking about derivatives a lot, and this chapter is going to be doing a lot of applications of them. So first off, when we think about a derivative, like a dy dx, what that is that is a rate of change in y as x changes, and we think about that as a slope or a rise over run. But basically, we want to think about that as some quantity is changing with relation to some other quantity. So how is y changing with relation to x? And just thinking about some basics, if dy dx is positive, what that means is as x increases, kind of as we go to the right on our curve, as x increases, y also increases. And that makes sense, as we saw in the last chapter, right? If my first derivative is positive, function increases. And if that first derivative is negative, what that means is as x decreases, x always increases, you're always going to the right. As x increases, in this case, your y decreases. So one of the things that we're going to think about here is units, because I think units are very instructive in actually helping us understand how to do problems. Don't worry, we're not going to do like sig figs or something dumb, but if you have, for instance, like, dv over dr, like, those are terrible variable names. Let's say dv over dx. So the units of this, the units of dv over dx are equal to the units of v divided by the units of x. And same thing, if you have like v prime of x, it's the units of v over the units of x. Okay, so let's look at an example of this. So say we have some lake. The amount of water in this lake, perhaps the world's famous Lake Borscht, the amount of water in a lake at time t is v of t, so some volume of time, equals 40 square root t minus 2t plus 5 gallons. So over time, this volume is changing. So part A, let's say of this problem, actually the only part we're going to do, we're going to say find the rate at which this volume is changing when t is equal to 4 minutes. Okay, so right away, when you see a problem like this and you see rate at which something is changing, that's talking about a derivative, right? So they're asking me to find the rate at which that volume is changing with respect to some time t. They're asking me to find that at t equals 4. Okay, so let's go ahead and do that, right? When we take a derivative, this is a pretty straightforward derivative. dv dt equals, so 40 times 1/2 t to the negative 1/2 minus 2. So we could also write that as 20 over rad t minus 2. Okay, now if I want to find this at 4, so if I want to find, say, v prime of 4, that's just 20 over square root of 4 minus 2, so that's 10 minus 2, which is 8. Now in terms of my units here, again, it's like the units of v over the units of t. So v is a volume, v is in terms of gallons. I should have put in the problem to include units. And then t is a time in terms of minutes, so we think about that as 8 gallons per minute. Think about that as a rate and think about the units in terms of time. I find to always be pretty useful there. So that's how you'd approach a problem like this, and that's how I want you to be thinking about these rates of change in the units. One other thing I wanted to talk about, say we want to talk about the units of v double prime. So remember, we write that as d squared v over dt squared. So as you might guess from this, it is like the units of v divided by the units of t squared. And you can kind of see that from the notation, right? We have a v, we have a t squared. It's just the units of those. So if I ask for like a second derivative in this place, that would be the derivative of the units of volume are in gallons, and that'd be in terms of minutes squared. So in physics, this is kind of like an acceleration type thing. Okay, so that's just talking about units and rates of change. This should be a great setup for the next video and get you excited for that. Okay, I'll see you soon.